Welcome to Summarize Science. Ever heard of a solar storm? These are massive explosions from the sun called coronal mass ejections, or CMEs. They hurl plasma and magnetic fields into space, and if one hits Earth, it can disrupt satellites, knock out power grids, and endanger astronauts. So, predicting them is a huge deal, but finding them in telescope images has been a major challenge. Traditionally, it's either done by a human expert, which is slow and subjective, or by older automated systems that often get it wrong. But what if an AI could do the job? That's exactly what the researchers in this paper explored. They used a powerful deep learning model called mask-RCNN, which is designed to not just find objects in an image, but to draw a precise outline around them. Here's the really clever part. Training an AI like this usually requires a human to manually outline thousands of examples, which would take forever. Instead, the researchers built a CME generator. They used a well-known geometric model to create over 100,000 synthetic, or fake, CME images. Each fake CME came with a perfect, pixel-level outline, giving the AI an ideal dataset to learn from. So, how did their synthetically trained AI perform on real solar images? Amazingly well. On validation data, it scored a near-perfect 98% accuracy. When compared to real CMEs outlined by two independent human experts, the AI achieved a 77% agreement score. That might not sound perfect, but consider this. The two human experts only agreed with each other 90% of the time, showing just how subjective this task can be. The model is also great at spotting multiple CMEs happening at once, a tricky scenario for older methods. You can see here how the AI cleanly separates the CME from other bright, fast-moving material in the background. It can even handle images from different telescopes that it was never trained on, showing it's very flexible. So, let's recap the important points. Researchers have successfully trained an AI to automatically detect and outline dangerous solar eruptions from the sun. This new method is fast, consistent, and performs very well when compared to human experts. The key breakthrough was using a massive dataset of over 100,000 synthetically generated CMEs for training, bypassing the need for tedious manual labeling. What does this mean for the future? It could lead to much better space weather forecasting, giving us earlier warnings to protect our vital technology on Earth and in space. This technology could also be deployed on future spacecraft, allowing them to autonomously identify important events and prioritize which data to send back, saving precious bandwidth. It's a huge step forward in how we monitor our star. Thanks for watching Summarize Science.